So welcome all. So we all hope that you had a great break. Now we continue. Remember, what we did is actually we tried to understand how economists actually they try to answer questions that they ask. And remember, we said that they use models, and we actually see how models work, how important assumptions are. We should be very careful about that. And then we actually saw some common features of these models, right? So, and starting today, we will actually start with the first sort of model. And we're going to see models of consumer behavior, okay? And we're going to, so this is going to be like, you can call this consumer theory, so this half of this course. And then remember, I told you that we're going to see firm theory, and then we're going to bring consumers and firms together, and we'll see how they operate in the markets, okay? So, remember, I asked you this before, but if you think of one of the most commonly used words in economics other than money, so what would you say?
Utility.
Not utility, but right, so probably, so we'll come to utility, but utility is a little bit fancier, right? But what we see other than, like we keep hearing money, and then there is this thing called demand and supply, right? So remember, I told you that we're going to learn what lies behind them, okay? So now we will start with actually the demand part, and we would like to understand what lies behind, the demand curve that you kept drawing in your introductory econ courses, right? So where does that curve come from? So you'll see that when we finish up consumer theory, you will know where your demand curve is coming from, okay? So what lies behind your demand? So basically demand you're going to see, but demand actually shows your choices, the choices that you make, okay? But remember what affects this demand. So what lies behind this demand curve? What lies behind your choices?
Price.
Right, so prices of goods, definitely. What else?
Disposable income.
So, I mean, it doesn't here in this course, we don't, he's saying disposable income, but we can say generally, right, income. And what else? What else, right? What you like, what you don't like, right? So, I mean, I'm not a big fan of, let's say, desserts. So, for some people, baklava might mean a lot of things, but for me, not, okay? So, this is, so it matters a lot. So, not only your income, your income, right? So like prices of goods. But what also matters is what you like, what you don't like. And as you guys were saying, actually we call this your tastes and preferences, right? So basically, so these are actually very important. So what we will do is that in order to understand your demand, and remember this part was determining what? We were calling it what? Prices, income, that was determining. No, just think of as a consumer, your problem, how would you call them?
Consumption.
Consumption. What's it? We also say it in Turkish as a budget, right? So these, that wasn't hard. So these kind of, you'll see that these will be related to your budget, and in this course it's going to be related with your budget set, okay? And this is also another part, right? So first you'll see, we'll start with this part. And then we'll introduce the constraint, right? So which is going to be your budget, which is unfortunately not unlimited. Then first we will understand this, then we're going to introduce the budget, right? And then we're going to see how, like you guys decide, okay? But now, this is going to be, so first let's start with your taste and preferences, right? So it could be the case that you like movies more than theater plays, right? So you might like Behzatçı, right? So for our international friends, it's actually, it was a cult Turkish TV series, okay, like about some sort of a detective, homicide detective. So actually, and then for instance, maybe you might like Behzatçı more than, what is it, Muhteşem Yüzyıl, okay? So, right, so that was also, again, for our international friends, that's again, was a Turkish series. Now I think a new one is coming up too, but it was about, Süleyman the Magnificent and such, and surprisingly it's very popular in, around the world. So, but anyway, so you might like one series more than the others, right? So you might like one dessert more than the other, right? So these are all, and it doesn't have to be the same, right? So Ayşe's preferences are like this, but like your friends, what's your name? Maripcan, okay, that was a hard one, but so it's so Maripcan's preferences are different, right? So basically, this is very important. But remember, we said that, okay, in this course we're going to deal with mostly math tools. So we would like to represent these preferences, right? How can we represent, when I say that I like Behzatçı more than Muhteşem Yüzyıl, right? How are we going to explain, how are we going to represent this statement, right? So via math. And you'll see that we can do it, and it's actually called, or for instance, you might like MacBooks more than PCs, right? You might like iPhones more than Samsung S5 series, whatever, okay? So it's, but how are we going to represent them? Okay, so that is a problem. So we can represent them via what we call a preference relation, okay? So I'll define what that is, but the issue is that how to represent them, okay? Basically, formally, how can we represent the statement that I like, basically, for instance, an iPhone 6 more than Samsung S5, right? So how are we going to say this formally, okay? So we can specify, in order to represent them, we can specify what we call a preference relation, okay? A preference relation. So what is this? So I'll give you the definition, and then don't worry, we'll go over the definition, okay? And try to figure out what they all mean, okay? So what is this, right? So what is a preference relation? So first, let's say, suppose we have actually this set X, okay, which is a subset of n plus. You're going to see n could be 2, then it would mean that we have actually, we're going to have what we call bundles of goods consisting of 2 goods, okay? If it's only R, it means that you're actually, it's like just a single, your bundle is consisting of a single good, so we'll see, okay? Suppose this X is actually set of all alternatives. So for instance, let me give an example. Again, we should always be able to explain everything in math to our grandma, right? So suppose n is equal to 2, right? And let's say that my X, like set of all alternatives, is consisting of X, Y, Z. And suppose X is Behzatçı and let's say 2 chocolate bars. Okay, so Y is, okay, I put this so that this was also a funny, like series that that they kept showing all the time at some point, okay? So, or you can tell me another, whatever series you want to, not very fancy, you want to put, I don't know. Okay, so there's also, these are, again, for our international friends, these are all like crappy, TV series. So it's, or we can actually have the, the foreign versions of that, right? So you can actually put Grey's Anatomy, you can put How I Met Your Mother, whatever, okay? So this is, let's say, Pisyedili and 5 chocolate bars.
Can I ask something?
Huh?
What is this 5? What's 5?
So this is an empty set.
Empty.
Okay. So that's an empty set, so that's one way of showing it, okay? And here we put muhteşem yüzyıl, okay? And let's say 3 chocolate bars, okay? So you see that this is your the set of all alternatives. Suppose, you're going to choose among them, okay? And this is your whole set of alternatives. So basically, so this is what we mean by the set of alternatives, right? So X is consisting of, you see these bundles of goods, and you see that these bundles, they don't have to be actually just goods that you buy. It could be a series that you watch, right? It could be how many hours you're going to sleep and such, okay? So this is going to be, so like these are what we call like bundles of goods, right? So these are consumption bundles, and you see that the set of all alternatives is consisting of these 3 alternatives, okay? So basically, so what if we would like to represent the preferences, right? I should have a way of saying that you are going to, because in the end you are going to compare this bundle to this bundle, right? You're going to tell me that, oh hocam, I like this more than this, I like this more than this, between this and this, I like this more than this, okay, whatever. So we are actually looking for a way to represent these, like your preferences, okay? So how to do that? So remember, we said that we're going to define a preference relation. So let me define it. So let's put this down. Oops. So basically, you want to compare any 2 elements of this set. Basically, this is what you would like to do. And then how consumers are making these comparisons, that would be their preferences, okay? So let me write this. So this is the formal definition. A preference relation, okay, is a binary relation. Okay, so one word that we don't want, concept that we don't know. What is a binary relation? What does binary mean?
2.
Right? So basically, it means that it's going to specify some sort of a relationship between any 2 elements of this set, right? Actually, we're going to define it over the set of all alternatives, okay? So it's going to specify a relationship between any 2 elements of X. Okay, so this is what we mean by a binary relation. Okay, gives a relationship between 2 elements of a set. So a preference relation is a binary relation, and usually we actually define the preference relation via this wiggly greater than or equal to sign. Okay, so you know what wiggle means, right? You know the song, right? So it's so it's this sort of wiggly greater than or equal to sign, right? So this is basically, it's a binary relation, and usually we denote it like this. Okay, so let me write this. Usually, bless you, denoted by this. Okay, defined on X. Okay, so this is satisfying. Okay, now new concepts come, but don't worry, we'll learn what they mean. Satisfying, completeness, okay, reflexivity, and transitivity properties. So you'll see that it's a formal way of saying I like this more than this, or you're going to see that I like this at least as good as that guy, the other guy, okay? So this is going to be, but apparently this sort of relation that we define should satisfy some properties, okay? Which are completeness, reflexivity, and transitivity. So we'll see what they are, okay? But, and usually, for instance, we actually say this: if x1, x2, so you can call this x1, x2 as the elements of the set of all alternatives, okay? So if x1 if you put like this relation here and then you say x2, we read this, okay, we should be able to read this. We read this actually as we say x1 is at least as good as x2. Right? So basically for me, let's say Behzatçı and 2 chocolate bars is at least as good as Muhteşem Yüzyıl and 3 chocolate bars. Okay? So if I write it x, so basically if I say x is at least as good as y, that's what it means. Okay? It means that, what does that mean? Do you think it definitely means that I like Behzatçı and 2 chocolate bars more than Muhteşem Yüzyıl and 3 chocolate bars, or it also allows for something else?
Also allows for equality.
Right, so it allows, we're going to, in the preference world, we're going to call it indifference, okay? But definitely, you'll see when we come to the utility world, it's going to be equality. But here we call them, you would be indifferent, right? So you're equally happy when I have Behzatçı and 2 chocolate bars, and when I have Muhteşem Yüzyıl and 3 chocolate bars, I'm equally happy, and we're going to call it I'm indifferent between them, okay? If you're equally happy consuming them, we're going to say that, or you're going to be indifferent, okay? So this is basically the case. So this is actually the sort of the definition that we give. So apparently whatever we say in words, if we would like to formally represent it, we're going to use a preference relation, but this is not any binary relation. It's a specific binary relation. It has to satisfy certain properties, okay, which are completeness, reflexivity, and transitivity. Now let's see what these are. Right now they don't mean anything to us at all. So now the first thing that we were saying, right, is actually completeness. So let's see. So what is completeness? So let me write down the formal definition first, and then I'll explain, okay? And remember, these are math tools. So whatever we are saying, our taste, our preferences, right now we're trying to express them, right? We're trying to represent them, okay? So basically this says that for any element in your x, okay, so for any x1, x2 element of x, where x1 is not equal to x2, either x1 is at least as good as x2, or x2 is at least as good as x1, okay? So if we would like to, so this is the formal definition. So what does this mean? Either you like, right? So between, if you make comparisons in any 2 elements of this set, x, you should be able to say either I like Behzatçı 2 chocolate bars at least as good as Muhteşem Yüzyıl 3 chocolate bars, or I say Muhteşem Yüzyıl 3 chocolate bars is at least as good as Behzatçı 2 chocolate bars, right? I should be able to say something. I cannot say I don't know. Okay, so this is basically, it might look, it doesn't look that fancy, but it looks, you know, too sort of technical. It might look too technical, but that's basically what it means, right? So you should be able to say either this or this between any 2 bundles. You cannot say, oh, I don't know. I don't know. You know which one I like. So basically this is what completeness means. So basically the individual should be able to compare. This is what it means, okay? So you should be able to, or let's say can compare, right? An individual should be able to compare between any 2 alternatives, okay? So the other one is
X1 eşitliğinde biz 2 yazdık sanki. Yani arada ama eşitliğe izin veriyoruz karşılaştırmada.
So okay, so let's actually, maybe this is a good time to say this, to make this actually remark. So your friend is right. So remember, I'm actually using this funny concept called at least as good as, right? So what does that mean? It means that, so this is what we said, x1 is at least as good as x2. So what does this guy mean? As you told me, hocam, this means that either I like x1 more than x2, right? It's what we call like there is actually, so you strictly prefer x1 to x2, or this also allows for another possibility. Remember the fact that you like them equally, right? Which is what we call indifference, okay? So here, this is actually how we define this. So if these are equal to each other, then you should be saying that x1 is at least as good as itself and x1 is at least as good as itself. So it's going to be, right, it wouldn't mean much, right? So if they are equal, imagine that if they're equal, so your friend is actually, so these are important. When you write down these definitions, from time to time you would have some clauses like this. So you should be able to see why it's there. So that's why he was asking. But this is going to, if these are equal to each other, then it would mean if this is equal to this guy, then I can always write instead of this guy, and instead of this guy. So this part is going to be true anyways, okay? So this is going to be the case, right? So this, as we see, this has two parts. One is what we say when you strictly prefer x1 to x2. You say, oh, hocam, I like x more than z, okay? So basically, let's write this. So this is here, either x1 is preferred to x2. So this has this part. And you know we show this as like this. If this is the case, then it's going to be wiggly, strictly greater than sign. Okay? So x1 is preferred to x2, or we actually have x1 is, so we can actually say, is indifferent to x2, okay? So this is basically, and if this is the case, we show it like this, okay? So we show that. So you see that this at least as good as, it actually includes two cases, right? One case where you are indifferent between x and z, right? Bundles x and z, and or a case where you strictly prefer x to z, okay? So this is basically the case, and these themselves are binary relations as well, okay? But don't worry about it, just know what it means, okay? So basically, so this is the case, okay? So keep this in your mind. So if we look at this guy, then, so what does this mean? x1 is at least as good as x2. Basically, it means either individual prefers x1 to x2, right? Strictly prefers, or let's put it like this. Actually, we can say it for completeness. So what does this say? Completeness says that, oh, when you have two bundles, either individual should be able to say, I like this first one more than the second one, or I like x2 more than the first one, or I'm indifferent between them. But the individual should be able to say one of them, okay? So that's basically what completeness means. Now let's come to this second property, reflexivity. It's going to be a funny one. So let's write that. Okay, so the second one is, as we said, reflexivity. Okay, now this basically would say that x1 is at least as good as itself. Okay, so this is a little bit sort of, you won't be able to explain it that easily to your grandma because it makes sense anyways, right? But let's write this. So for all x1 element of x, x1 is at least as, I could have put x here too, okay, if you want I can put x. X is at least as good as itself, okay? It means that for any alternative in this set x, it should be at least as good as itself. So that is, there's not much to say here. Okay.
Similar to each subset is a subset of itself.
You can actually think of it, so this property is there so that you would actually prove some other properties, okay? So basically, but it's, right, it makes sense, right? But there is not much to explain there, right? So it's basically, that's what we say. So let's actually write this for any, so let's say any alternative is at least as good as itself, right? So as your friend was saying that any subset is actually a subset of itself, right? So any set is a subset of itself, so that's the better way of saying it, right? So going to a movie is at least as good as going to a movie, right? Otherwise, things would be really weird. So this is basically the second property that a preference relation should satisfy. This third one is important, and you'll see that it will be very important in showing some stuff later, and you'll come across this a lot. So it's actually transitivity. Okay, so again, let me write down the formal definition and then we'll explain what it means. So basically, transitivity means for any x1, x2, x3, okay, in this x, if x1 is at least as good as x2, and x2 is at least as good as x3, okay, then what would you expect? If I tell you that, I erased our choices, so let me write down here. So remember, so this was Behzatçe, what was it, 2 chocolate bars, and we had Y, which was pis yedili, and how many? 5 chocolate bars, right? And then we had Z, this was Muhteşem Yüzyıl, 3 chocolate bars, right? So remember, this means that if I say X, Behzatçe, and 2 chocolate bars is actually, for me, at least as good as Muhteşem Yüzyıl and 3 chocolate bars, and Muhteşem Yüzyıl and 3 chocolate bars is at least as good as pis yedili and 5 chocolate bars, then what do you think I should say? If I'm a consistent, person, what should I say? Should I say that, for me, pis yedili and 5 chocolate bars is at least as good as Behzatçe and 2 chocolate bars? Do you think I should say that? So suppose I said this, X is at least as good as Z, right? Z is at least as good as Y. Then what should I say? Right? X is at least as good as Y, right? So if I say, X is, so basically let's put this, but then I actually say that here, so we can actually put this, or we can put it, right? So I said this is at least as good as this, and then this guy is at least as good as this. If I say Y is at least as good as X, you would say, hocam, right? That is not very consistent, right? Because you said that you like this guy more than this guy, you like this guy more than this guy, so this guy seems like the worst guy to you, and then now you come and you say that, I like this guy more than this guy, right? So that is not very consistent behavior. So this is basically what transitivity says, okay? It says that if you like this guy more than this guy, or if x1 is at least as good as x2, x2 is at least as good as x3, then, right, as you guys told me, x1 should be at least as good as x3 as well, okay? And by the way, don't worry, this is going to be the sort of the more conceptual and sort of a little bit of abstract math part, but don't worry, like in less than half an hour we're going to be dealing with numbers, okay? But we have to understand where they are coming from, okay? So don't worry about it. All I need is that you understand what are apparently the preference relation which we use to represent our preferences. They should satisfy certain properties, and what do they mean, okay? So this is basically the case, transitivity. This is what we said, right? So if you like, remember, and then we can actually put it there. So let's put our example, right? So we said that if you like Besatçe more than, so let's put it Z, Muhteşem Yüzyıl and 3 chocolates, and if you prefer, if you say Muhteşem Yüzyıl and 3 chocolates is at least as good as Y, PCD'li and 5 chocolates, okay, then you should basically like, that's what we said, Besatçe with 2 chocolates to PCD'li as well, okay? So this is basically the case. So this is what transitivity says. So it means that you're basically, you know, whenever you say this is at least as good as for me, whatever you say is internally consistent, okay? So this is important. So basically all these 3 properties, they kind of mean that you can compare, and you are, when you compare, when you make these comparisons, and when we look at them all, they're actually internally consistent. So you're not that crazy, right? You're not that crazy once you say, oh, I like this more than this, and then you change it, and then immediately, and then say that, oh, I like this more than this. No, it's actually, there is some sort of an internal consistency, okay? So why do you think we would need this internal consistency? Do you think we don't allow for people who are, you know, crazy, or who are making not internally consistent choices?
Simplification.
So actually I mean, there are people like that, right? But we need this, you're going to see that, so that we can use math, okay?
The math is objective, I think. It will not be subjective.
So it's and the issue is that you're going to see that we would like to use numbers, right? And whenever we use numbers, and you'll see later, we would like to use functions. So whenever we have them, we would like, just as we would like to say that 10 is greater than 9, right? We want consumer to be able to say that, you know, 10 is greater than 9 as well, okay? So if I like one thing really the most, then I shouldn't change it, right? I shouldn't change it. I should be whenever I make these pairwise comparisons, I should be consistent, okay? So you'll understand why. But as I said, that all I need is that know what these mean, okay? So if what completeness, what reflexivity, so there's not much to know here, but what transitivity means, okay? So this is actually important. Because, why I said this, because you see that this preference relation and these properties are very much related to the concept of, probably you've heard, rationality and rational agents, okay? So I'm going to write down what it means again, and then I will explain. So basically, so this is, you'll see that whenever we call you guys rational, actually we implicitly, there is actually an implicit relation to these properties, okay, that you guys are able to compare, and your basically your comparisons are, your pairwise comparisons are internally consistent. Basically you're not that crazy, as I said that. That's why we tend to call you you know, like rational, okay? So let me actually say it to the relation to rationality. So relation to rationality. Okay? As I said, that if these are too abstract for you, just think that, okay, these mean that we're not that crazy, and know what they mean, okay? So this preference relation concept is closely related to the concept of rationality, okay? And let me say this, an individual is considered as rational, okay? So we call you rational if she, he makes choices, okay, as if she is or he is maximizing a preference relation. Okay? So we call these type of individuals rational. But as I said, that you can always think of it that, okay, so this rationality concept is kind of related to right, these properties that we specify here. Okay? But it's not enough. You should be acting as if you're maximizing a preference relation, right? Basically, you're choosing whichever one is best for you, okay? Among those set of alternatives. Basically, that's when we call you rational, okay? So basically, or but as if when you, it's actually the, like as if you act as if you're maximizing a preference relation, okay? So basically just keep this in your mind, and there is actually another property, so you'll understand what these mean, but later, and as I said, that just know that we need these guys so that later on we can use functions, okay? So the other property that we're going to actually use, but that has nothing to do with this rationality concept and such, is continuity. Okay? Do you remember from your calculus classes what continuity meant? Right? Do you remember? Yes? Okay, so it's so don't worry, I'll write down the definition and then we'll give a break. Okay? But basically, continuity is very similar to whatever you have learned in your calculus classes. So, but what it means, again, the grandma explanation, it means that we don't want you, not only we want you, like to be sane people, not to be crazy and such, but we also want you not to have lots of jumps, ups and downs in your preferences, okay? So this is going to be what continuity will guarantee us is this, but actually the reason why we are going to make this technical assumption, because if you tell your grandma that, if I'm going to consider you rational, like if your preferences satisfy continuity, your preference relation satisfies continuity property, that is not something that, she could have jumps, right, ups and downs, that doesn't mean that she's not rational, okay? But the issue is that, remember I said that we would like to use functions, we would like to use math, and then not only we would like to use functions, we would like to be able to differentiate them, right? So that's why we need continuity, okay? So that's basically why we need it. But there is also, again, as any math concept, there is actually, we can find an intuitive explanation, okay? Basically, we can find an economic intuition to that, okay? So this is the other property, which we call continuity, okay? So let's put this down. The fourth one, okay? So this is kind of a technical sort of assumption that we have, but again, you see that we will be able to explain it to our grandma. So this is continuity. Okay? So basically, what I'm going to write down, I'm going to write a more technical definition and kind of a more intuitive definition, okay? So the first one that I will write is the more intuitive definition. So here, basically, take x is Rn plus, okay? So this is not the technical definition that I'm writing. For all x, y, z in x. By the way, don't get confused. Sometimes I write x, y, z in x. Sometimes I refer to the elements of x as x1, x2, x3. Okay, this is just notation, right? So this is, I could have said x, y, z as well. Okay, so don't get confused. Sometimes I think I said x1, x2, and sometimes I use just x, y, z. Okay, it doesn't matter. So basically, continuity means if y is at least as good as x, okay? So if I know that for me, let's say that PC'li, as I said, that these were for Ayşe, for instance, the stuff that I said, but for, what was it? Maripcan. Okay. So Maripcan, I picked probably the hardest name in the class, but it's a beautiful name. So, but you know, like Maripcan, right? So this is basically right. So, but maybe for him, he likes, you know, somehow he's not that cool, right? So he likes PC'li and 5 chocolates, right? More than Behzatçı and 2 chocolates. Okay, that could be the case. So basically, but you see, it's preferences, right? It's tastes. We cannot, so everyone's tastes, everyone's preferences could be different, right? That's the whole point. So this is actually the case. But even if that is the case, then if this says that if y is at least as good as x, okay, then for basically any bundle z, okay, which is very close to y. Suppose I know that he likes y more than x, for instance, but then it says that for any bundle, okay, suitably close to y, what do you think? If we don't allow for jumps, you know, like ups and downs, then what should be the case? So suppose y is at least as good as x and z is very close to y. Then what, if it continues, what would you expect? Z is at least as good as, right? Again, x. Right? So this is what we mean by continuity. So you don't suddenly reverse. So suppose this is y is here, okay, and you know that y is better than. So there is actually a z which is very close to y. Of course, if we, you know, let's say, represent everything in the, you know, like let's say the positive quadrant or whatever, okay? If it's very close, then if I say that this is at least as good as x, then this z should also be at least as good as x, okay? So this is what we mean by continuity. So let me write this, suitably close to y. So we actually said that we have, right, so we have z at least as good as x as well. Okay? So as I said, that this is not the technical definition, but this is more intuitive. That's why I like this. But let me provide you the technical definition. Okay? And then, so let's actually have this. For any sequence of bundles, okay, yn in x, suppose, if yn is at least as good as x for all n. So it says that suppose you take a sequence, okay, of bundles. So don't forget that this sequence is actually consisting of bundles like this. For instance, if n is equal to 2, it's like this. Then it says that take any sequence of bundles, okay? And for all in that sequence, for every element, you can say this, okay? Then if this sequence is converging to y, then what can I say between y and x? This is actually the formal definition of continuity, right? It means that this should be, right, so y should also be at least as good as x, right, if they converge to y. So this is basically what we mean by continuity. But again, as I said, that probably this wouldn't mean anything to your grandma. Your grandma would understand that, oh, we don't want sudden reversals, right? Immediately, z is very close to basically y. But when I ask you, you tell me that, oh no, I like x's better than, or for me x is better than z. Okay, we don't want you to say that. You can say it, by the way, but then we won't be able to represent, you'll see that your preferences by a utility function. Okay, so that's basically that's the problem. So let me write this: if yn is at least as good as x for all n, okay, and yn, so this series converges to y, okay, then we actually say we want y should be at least as good as x, okay? So this is a more formal definition than this one above, okay? But basically we do not want sudden reversals, okay? So let's actually say this means no sudden jumps or reversals. Basically, this is what we mean, okay? But if your grandma's preferences actually have sudden jumps, ups and downs, she could still be rational, okay? But as I said, that this is a technical assumption that we require so that her preferences can be represented via functions, okay? So you'll see, all right? So let's give a break and then we'll continue for the second hour.